All right, looking at number three. Number three essentially is still all those exponent properties that we are working with today. But now we're just going to have more algebraic expressions. We're not going to be able to evaluate these into actual numbers. We're just going to be using exponent properties to simplify as much as we can. So looking at part A, we have an expression times an expression. So I would say here, a lot of people will look at this and see parentheses and then think that they have to somehow distribute or anything like that. But basically we're multiplying all of these factors together. And so I could write this problem as 2 times x cubed times y to the fifth. It's really just one thing here. Times negative 5 times x to the fifth times y times z cubed. And all I'm going to do here is just multiply the terms that have a common base. So if you look at the things that have a common base, we have the x's, we have y's, and that's it. So just for this first example, let me just rewrite this to make it really, really obvious. So I have 2 times, and I have my x's. So x cubed times x to the fifth, I'm going to multiply. And then I'm going to multiply the y's. So y to the fifth times y. And I'm also going to have my times z cubed in there. And I can't forget about that other number right here, negative 5. I'm going to put that negative 5 next to the other number on the left-hand side. So really the only thing I've done here is just sort of talk it through and just jumble these factors and kind of rearrange them. Okay, because in my mind, going from these two things, multiplying that, I'm just thinking of the common bases. I'm going to multiply the x's, I'm going to multiply the y's, and I'm going to multiply the numbers. So this is really kind of what I'm seeing in my mind when I'm multiplying. But when you first come across these, you might not see it like that. So then we just go to each group and we just say, okay, well, negative 5 times 2, well, those are just numbers. I can evaluate that. That's just negative 10. Then we're going to take the x's, and since we're multiplying, we're going to add the exponents. So that gives me 8. The y's, I'm going to also multiply and get 6. And then for the z's, there is nothing to combine with the z's, so that stays as z cubed. So that's for the first one. We can't go any further than that because we don't know what x, y, or z are. All right. Again, try these next two, and you can always fast forward and kind of just see if you get the answer. Okay, or you can always rewind and get the explanation. All right, so for part B here, again, I'm multiplying two things, but since there is exponents here, I have to take care of those first. So really what I'm doing is I'm going to take this 2, let's say for the first one, and I have to apply it to each term inside of the parentheses. So I'm going to have to take 2 squared, right? I'm going to have to take 2 squared and make that a 4. And then I'm going to have to take x to the fifth raised to the 2. X to the fifth, and if that's raised to the 2, that's a power of a power property. This is now going to become x to the 10 because I'm going to multiply those exponents. Same thing with the y to the 6. If I have y to the 6 raised to another exponent of 2, I'm going to multiply those exponents and get y to the 12th. Now I would do the same thing over here. Let's kind of do the same thing over here. We have this expression raised to a negative 1. And so everything, that whole product inside, is going to be raised to the negative 1. So you can, this little negative out here is actually not part of the power 2 to the third power. So it's a little tricky. You can think of this as negative 2 times 2 cubed in there, technically. So really I'm taking negative 1 and I'm going to raise it to every single term inside that product. So if I write everything out, it's going to look like this. I'm going to have negative 1 raised to the negative 1. Then I'm going to have 2 cubed. I'm going to raise that to the negative 1. Okay. Then I'm going to have y to the negative 5th. And that's raised to the negative 1. So I'm writing this step in here. Over here, I didn't actually do that secondary step. We just multiplied it out. But this is actually what we're doing here, is we're taking every single term inside that parentheses and raising everything to the negative 1. So this right here becomes just a normal 1, which kind of goes away. Here we multiply, so we have 2 to the negative 3. And then over here we have y to the 5th. So if I bring everything else down, let's bring this down here. Okay, then I'm left with all of this multiplication again. Really, it's kind of the same thing as the problem on the left. So if I take this, and I won't rearrange everything this time, but I have a 4 that's common with the 1, or at least I could evaluate those. 4 times 1 is just 4, right? Then I could take the x's. Actually, we have more than that, right? We have a 2 to the negative 3 in there. I'm going to put that down here as 2 to the negative 3, because that's still a number also. Then let's go to the x's, right? So we have an x in here, and there's no other x available. So that's not going to be able to multiply with anything else, so that's going to stay as x to the 10. Then I have the y's. So here are the y's. I have y to the 1st, then I have y to the 5th. So if I multiply these, again, I'm just going to add the exponents, just like before. So that becomes a y to the positive 6. So now we're getting further and further. The next thing that we would do is take any negative exponents. So this guy right here, okay, 2 to the negative 3. If I want to write that with a positive exponent, all I'm going to do is, again, I'm going to bring that 4 down, and I'm going to write this as 1 over 2 to the positive 3. Now I know that 2 to the positive 3 is just 8. So really this is 4 times 1 over 8. Or 4 over 1 times 1 over 8. Well, that's 4 over 8. Or just 1/2, right? Now nothing really happens to this x to the 10 and the y to the 6. So I'm going to bring that down basically, and this is going to be times x to the 10 and times y to the 6th. So some of these, while each one individual step isn't so bad, when you start doing problems like this, and there's a lot of little steps in there, it can be complicated. You have to take your time on it. You have to go step by step. You want to be able to understand why you're doing each step. And again, I know this isn't the most ideal thing is for me to be talking on a video while you're doing this, because you can't ask questions. But again, there should be a spot to ask questions, and that hopefully we'll have a live kind of Q&A as the week progresses. So do the best you can, and save your questions. All right, and let's go to the last one here. Okay, so we have part C. Now really this, you can just break this problem up. Everything is divided. So I would just take the numbers kind of separately. 12 divided by 27. And then I would take the next set here. X to the negative 5th divided by x squared as kind of a separate problem there. And then take the y's separately. So you don't actually have to write this step out, but I like to think of it and just break it up into 3 separate problems. And then just reduce those 3 separate problems. So the first thing is we want to look at the numbers. and we can go ahead and reduce that fraction. So we can divide the top and the bottom by 3. So this will become a 4 over, and this will become a 9. So this will be 4/9. And then we would bring down the x's. So now I'm dividing. I have x to the -5th divided by x squared. And so this is going to be x to the -5 minus, I'm going to subtract, -2. So this is -7. Then I'm going to take the y's, and I'm going to say y to the, I'm dividing again, so 10 minus a -4. So that becomes 14. Now, just so I have kind of some consistency here, I'm going to go ahead and put all these over 1, just so I have like 3 fractions. You can see I have numerators and denominators in here. And I can put these back together. But oftentimes, we could just write this as our answer. We can just kind of put the numbers together, clean it up a little bit, and be done. But oftentimes, we want to write our exponents as positive exponents. Or a lot of times the instructions will say that. So what I'm going to do is I'm going to adjust this one right here. And I'm going to make that a positive exponent. So instead of x to the -7, I'm going to make it x to the +7. But in order to do that, I have to take it and put it on the bottom. So this is going to be x to the +7, or 1 over x to the +7. And the rest of my numbers are going to stay the same. So I have y to the 14th. I bring all that down. Now the very last thing, my answer here, I can just multiply the tops and the bottoms together. I'm just going to put these all together. So on the top I have a 4 and times a 1, so 4 times a y to the 14th and divided by a 9x to the 7. And so that is going to be my final answer.